The pursuit of efficient has driven innovation in various fields, particularly in technologies aimed at reducing human effort while maximizing output. One such innovation is the concept of a hand water pump powered by a pendulum. This seemingly simple yet profoundly effective solution offers an ingenious method for pumping water with minimal physical exertion. The hand water pump with a pendulum not only challenges conventional designs but also promises significant advancements in areas where access to water is critical, such as small-scale irrigation, well water extraction, and emergency firefighting. At the core of this innovation lies the pendulum, a device known for its ability to maintain oscillation with minimal energy input once set into motion. The hand water pump utilizes this principle by incorporating a pendulum that, once initiated with a slight push, continues to swing and drive the pump's piston. This process transforms gravitational potential energy into kinetic energy, which in turn generates a continuous flow of water. The operation is straightforward. To begin pumping water, the pendulum must be set out of balance. As it swings, the connected piston oscillates, allowing water to be drawn up through the pump and expelled through the output pipe. The key advantage is that maintaining the pendulum's motion requires only occasional, gentle pushes, which can be accomplished with just a finger. This minimal effort contrasts sharply with the physical strain typically associated with conventional hand pumps, where sustained, vigorous pumping is required. Efficiency and practical applications. The hand water pump with a pendulum offers several notable benefits over traditional hand pumps. The primary advantage is its efficiency in terms of energy input versus water output. It is possible to pump up to 1,000 liters of water per hour with this system, an impressive feat considering the minimal effort required to keep the pendulum swinging. This efficiency makes the pump particularly valuable in situations where continuous water supply is needed over extended periods, without causing user fatigue. Furthermore, the pump's design allows for hands-free operation once the pendulum is in motion. This feature frees both arms, making it easier for users to fetch and transport water. The simplicity of operation also means that the pump can be used by a wide range of people, including the elderly and children, who might struggle with traditional hand pumps. The pump's utility extends beyond just water pumping. Its underlying principle, leveraging a pendulum to reduce human effort, can be applied to other devices that use lever mechanisms, such as hand presses. This adaptability further enhances the potential impact of the invention, making it a versatile tool in various applications. Addressing misconceptions and challenges. While the concept of a pendulum-powered pump is compelling, it is essential to clarify certain misconceptions, particularly those related to overunity claims. Overunity, the idea that a device can produce more energy than it consumes, is not supported in this context. The pendulum-powered pump does not generate excess energy, rather, it operates on the principle of efficiently converting small amounts of input energy into sustained mechanical motion. After the initial push to set the pendulum in motion, small amounts of energy must be continuously added to maintain its oscillation. This energy input is comparable to the process of maintaining a diesel engine's operating temperature before measuring its efficiency. Similarly, just as the energy used to magnetize permanent magnets in an electric motor is not included in the motor's efficiency calculations, the energy used to initiate the pendulum swing is not the focus here. Instead, the emphasis is on the minimal energy required to keep the pendulum moving. However, the pump's operation involves complex mechanics that require precise measurement to accurately calculate its efficiency. The force exerted by the pendulum on the lever is variable, which adds a layer of complexity to the mathematics involved. Additionally, the two-stage oscillator design, with its movable pivot point, introduces factors like acceleration and energy loss due to movement, which must be carefully considered to optimize performance. The Ultimate Energizer Guide. This technology is essentially an improvement on the Joule Thief circuit and Don Smith's circuit, resulting in a unique version. The deep origin of the Ultimate Energizer generator traces back to Nikola Tesla's innovations. Tesla's invention of the bifilar coil and regulator for dynamo electrical machines is documented in the complete Ultimate Energizer Guide. The Joule Thief circuit and Don Smith's circuit, although capable of producing output energy greater than input energy, are primarily intended for free energy researchers. Those who demonstrate these circuits often do not share the secrets of generating electricity to power household appliances. The Complete Ultimate Energizer Guide reveals the secrets of generating electricity using electronic components and coils, with power output depending on the system's expansion. This sets it apart from the Joule Thief circuit and Don Smith's circuit, which are commonly shared online. Moreover, the circuit described in the Ultimate Energizer Guide is unique and distinct from the Joule Thief circuit and Don Smith's circuit. The Complete Ultimate Energizer Guide also includes many other instructions and hidden technologies that have been concealed for many years. This digital document is worthy of study and practical application. I recommend reading more reviews of the Complete Ultimate Energizer Guide on my Ultimate Energizer Guide blog. Also, check out additional instructions for generating free electricity at home. Good luck!